Today I built a real local file sharing app that works on any device connected to the same Wi-Fi network. No cloud, no login, no internet needed. This entire section is the main interface of the application. Everything the user can see and interact with is inside this single container. At the top, I display the app name using an h1 tag, which clearly shows the branding of the project as local share. Right below that, I add a subtitle that explains exactly what the app does in one sentence. It tells the user that they can share files on their Wi-Fi between devices. Next comes the address box. This section shows the exact link that other devices on the same network must open in their browser. The span is just a label for the user, and the code element is dynamically filled by JavaScript with the real local address. After that, I add the device name section. This lets the user enter a custom name for their device, such as a PC, phone, or laptop. This name is later attached to every uploaded file so other users can see who sent it. Then we reach the most important part of the app, the file sharing area. This drop area allows users to either drag and drop files directly into the box or click to manually select files. Inside this area, there is a hidden file input element that actually handles the file selection in the browser. The visible button is what triggers that hidden input using JavaScript. Below the drop area, there is a status div. This is used to display real-time messages such as uploading, upload complete, or upload failed. Then I add a heading called available files, which separates the upload section from the download section. Finally, there is an empty files list container. This div is automatically filled by JavaScript with file cards whenever someone on the network uploads a file. Each card represents a file that can be downloaded by any connected device. So this entire div acts as the full user interface for the local file sharing system, from connecting devices, uploading files, showing status, to downloading shared files in real time. Now we create style.css file and start styling our web application. For the styling, I used modern CSS to give the app a clean glass morphism look with smooth gradients, soft shadows, and responsive layout so it works perfectly on both desktop and mobile. I'm not going to go through every CSS line right now because it's mostly visual work, so I'll just speed up this part in the video. The focus here is the functionality, but the full polished UI is included in the final project. I'll upload the complete source code, HTML, CSS, JavaScript, and the backend to my GitHub repository so you can download it, run it locally, and customize it however you want. This JavaScript file controls the entire logic of the application. It handles real-time communication, file uploads, downloads, and live UI updates. At the very top, I connect the client to the server using socket.io. This allows the app to receive real-time updates whenever a new file is shared by any device on the network. Then I grab all the important elements from the HTML using their IDs. This includes the address display, device name input, drop area, file input, select button, status text, and the files list container. Next, I display the current website origin inside the address box. This is what users open on other devices to connect to the same file sharing session. After that, I define helper functions. One formats file sizes into readable units like bytes, kilobytes, and megabytes. The other formats timestamps into human readable time. Then I build the render files function. This function clears the file list and dynamically creates a visual file card for every shared file. Each card shows the file name, file size, the sender's device name, the upload time, and a download button. When the download button is clicked, the file is downloaded directly from the server. Next comes the load files function. This function fetches the list of available files from the backend API and passes them to the render function. This runs when the page loads and also whenever a new file is uploaded. After that, I set up all the drag and drop logic. When a file is dragged over the drop area, the UI highlights the box. When the file leaves or is dropped, the highlight is removed. Clicking the drop area also opens the file picker. I then add support for manual file selection using the hidden file input. When the user selects files, the upload process automatically starts. The upload files function handles the actual file transfer. It detects the device name, prepares the file data using form data, and sends each file to the backend using a post request. While uploading, the status text shows real-time feedback such as uploading, success, or error. Once all uploads are complete, the status message is cleared after a short delay. Then I listen for real-time socket.io events from the server. Whenever a new file is uploaded from any device, the server emits a file added event, and this triggers the app to refresh the file list instantly on all connected devices. Finally, at the bottom, I call load files once when the page loads so that any previously shared files immediately appear in the interface. This file is the backend of the application. It is responsible for serving the website, handling file uploads and downloads, and enabling real-time communication between all connected devices. At the top, I import all required modules. Express is used to build the web server. HTTP is used to create the server instance. Socket.io enables real-time communication. Multer handles file uploads. Path and fs are used to manage file paths and the file system. Next, I create the Express application, wrap it inside an HTTP server, and attach socket.io to that server so all three work together. After that, I make sure that an uploads folder exists on the system. If it does not exist, the server automatically creates it. This is where all uploaded files are stored. Then I configure Multer's storage system. I define where files should be saved and how they should be named. Each file gets a unique name using the current timestamp and a random number, while preserving the original file extension. Next, I create Multer's upload handler using that storage configuration. After that, I create an in-memory array to store metadata about the uploaded files. This array holds the file ID, original name, stored name, file size, file type, the sender's device name, and the upload time. Then I tell Express to serve the front-end files from the public folder. This allows the browser to load the HTML, CSS, and JavaScript interface. Next, I create a simple API endpoint that returns the list of all uploaded files in JSON format. This is what the front-end uses to display available files. Then I define the upload endpoint. When a file is sent from the browser, Multer processes it and saves it to disk. I extract the device name and file information, build a metadata object, store it in memory, and immediately broadcast the new file to all connected clients using socket.io. After that, I create the download endpoint. When a user clicks the download button, the server looks up the file by its ID and sends the real file from the uploads folder back to the browser. There is also an optional debug route commented out that can be used to delete all uploaded files and reset the system during testing. Next comes the socket.io connection handler. Whenever a new device connects, the server logs the connection. When a device disconnects, the server logs that as well. This keeps track of active clients. Finally, I start the server on port 3000. Once the server is running, it prints the local address in the terminal and tells the user to open the same address on their phone using the local network IP. So in summary, this entire server.js file acts as the backbone of the application. It handles real file storage, real file transfers, real-time updates between devices, and serves the full front-end interface, all running locally without the internet. Alright, now let's test this in real time. I've got my server running locally, and the app is open in my browser. At the top, you can see the local address that other devices on the same Wi-Fi network can open to connect instantly. I'll first set my device name to PC so it's easy to see where the file is coming from. Now for the actual test, I'm going to upload a file using drag and drop, no file picker, no extra steps. I just grab a file from my desktop, drag it directly into the drop area, and release it. As soon as I drop the file, the status switches to uploading, and the file is sent straight to the server in real time. A few seconds later, the upload is complete, and the file instantly appears in the Available Files section below. You can now see the file name, the file size, the device it was sent from, and the exact upload time. And at this point, any device connected to the same Wi-Fi network can immediately download this file with a single tap, no cloud, no login, just instant local transfer. Downloaded on my phone in seconds, straight from my PC, no cloud, no Wi-Fi. Subscribe before I upload another banger without you.